if YouTube is up or not. And it is still trying to connect. And the audio level is good enough. Okay, and I hope I'm audible now. I guess my voice is very feeble at the moment. But still not much, so we can use this. And now I have put mic very close to me, and I hope the voice is better. Okay. Let's get started. And let me see if the comments are working or not. And comments are working. Right, so we were trying to make sense of how the signals will work. So we have three systems, right? One is like RSP processor. Let me decrease the font size. So this is the RSP processor. This is a box. So this will signal 2 to 3 kind of thing, right? It will signal new node added. It will signal start account. What are the signals we have? Let's check. The other signals we have are it will also signal send to master, and will also signal send to replica. And there will be data. Data will be processed by the request processor. So this will be sending data. That is the request. And then there is a signal handler. Signal handler will clone send to all of them and will receive at one end. But this request processor also need to ensure that it can receive like new node added. So this new node added needs to be is something that needs to be received by everyone, because we need to return the stream. So how would we ensure that this thing is shared among both? How can we do that? So we can create one more signal called as new node added signal, and that will ensure that we can exit out of the, like, we can remove the stream ownership Or is there any way where I don't have to listen to the stream? Let's check. So this is where stream is being read. It will lock and drop, but this might block for a long time. So actually before reading, we need to find out, is there a way I can know if there is some value there in there or not. So read ready or something, no? So let's see if we have stream.read, and I hope this is not standard stream. What kind of stream is this? This is a TCP stream which is from Tokyo.net. Okay, so only read if you have some values in here. All read ready. If the TCP stream is not currently ready for reading, this will store a clone of the waker from the provided context. When the TCP stream becomes ready for reading, it will be called on the waker. Not that on simple multiple calls to call.read, call.read, call pick on the waker from context passed to much of this feature intended for cases where creating or pinning a feature variable is not feasible. Okay, let's see readable. Okay, so this method is cancel safe. Once a readiness event occurs, the method will continue to return immediately until the readiness event is consumed by an attempt to read that fails with would block or poll of pending. So wait for the socket to be readable, and once it's readable, we'll try to read it. And before this thing is done, I need to be able to this whole stream is behind a toggle. So this thing hid the stream. Now this is behind the stream. And I cannot consume the stream. So either I can just make it a stream and then wait for it to be ready and then lock it. But here we are locking it, and then this await thing will take a lot of time. What if we do try read instead of read? And what does this try read do? Try read is a function receive any pending data from the socket but does not wait for new data to arrive. Once success, returns the number of bytes read. Because try read is non-blocking, the buffer does not have to be stored by the sync task and can exist entirely on the stack. So this should work now. And does this take ownership? No, this is immutable. So this now won't be, this will return after a while. So try read is okay. And what about write? This is require mutable ownership of it. So this is where we need to take a lock. And there also we need to take a lock, but it could have been just a read lock. Maybe we'll allow multiple people to read from it, maybe not. Since this is a resource, it needs to be behind a lock. Or how about we separate reading and writing? Since in the replica case, will we ever read? I guess we will read. But yeah, that's try to run this. We'll start the replica here. Replica started and it crashed. This is saying connection reset by peer. So after the res error, reading from TCP stream operation would block. What does this mean? Let's see. Connection is not ready to work here. So this is when we got Pong. Ah, so this is happening after we got the response. So this is the write all, and this stream is not ready to write here. Error, reading from. Okay. I really need to convert all of these statements to good print statements. So yeah, that will take a lot of time. So I won't be doing that now, but I also need to debug this particular thing. So why is this failing? Is something that I'm not sure. Okay, and this replica thing failed at the time when reply from master Pong, and it was connection reset by peer at 217th line. This is weird. Yeah, 217th line, which is here. Reader.read send commands to master. And it's using the same stream. Okay, so this is now would block on read. Weird errors. (217) cannot read, and it would block. Okay, I guess the important question now is let's go back to the whiteboard, because I think I'm getting into a corner where I cannot, come out of. So this whole stream handling should happen at the top level. I guess all of these signal handling should happen at the top level, where there is one person who handles the whole stream and everything. But this guy, this should know when to exit out of the loop. How will this know? This will know by signals, and this is the signal that it wants to listen to. So there should be a signal manager which will send signal to various parts of the program. So there will be signal receiver. There will be one receiver here. Do we have multiple producers, single consumer? Do we have MPMC? MPSC, Rust. Do we have subscriber or something? No, not this. This is for tracing. But yeah, one thing we understand is we need a easier way to do this. So every one of these will have a receiver and a sender. Receiver, all of the receivers that they are getting will be from one single function. So there should be a struct call which will contain vector of receivers and will contain senders. Now there will be senders can be, there will be one sender which will be returned to every one of them. This will have one sender, this will have one sender, and all of these will send some messages to the program. And so suppose I did sender.send new node added, then the stream will be listening for this new node added, and there will be another person somewhere here which will be listening to that. Okay, so at every moment they will be listening to one particular event. So there's multiple sender and one receiver, and every time this particular thing got any command, like if it got any values here, it will send to rest of the values. Right, so we need a way to get the events. So events can be this thing, this thing, this thing, and this thing. Okay, so somehow I feel like I'm just making it very complex. So there is this signal handler. Where is that person? I guess we can reuse that signal handler, signal sender. So this is useful for sending some signals, and there is a signal receiver. So these are all kind of messages that can be there, but there can be multiple messages that can be sent, which is okay, and some can be, let's see, what do we have anything special for signals? Sync sender. All of them are either sender or receiver, and let them be async. I guess that will be better. And we need all of them to be one channel. Okay, so send to master, send to replica are good enough. Count toward offset is also good. And when will I know that I have done this thing? So these are like uh, so these will be like let's see, one shot channels. This data can be one shot. They cannot be one shot because this needs to be running all the time, and his job is to just transfer signals. But how will it? How will they make sure that request and response are matching? Like we also have request and we also have response that needs to be sent to replicas. Right, this will send response as well. We don't need request per se. But yeah, so these are tags that can be added, I guess. So these tags are added, and we need one mechanism to know. So this signal is something that these have. It's just that we need a common argument here, something that can be shared. How would I share receivers? Cannot share receivers, but we can share senders, and every function can have one receiver. Okay, so let's okay. So the only thing I needed to solve this issue currently, the issue that I'm facing is related to this particular thing where there are multiple replicas, so it's somehow crashing, because not crashing, it cannot send to another replica because the read thing is blocking the whole pipeline. Now the error is different now. I mean, it's different, but the only issue is that receiver can only be one. So I guess the person who owns the stream must be responsible for writing the data, reading the data. So yeah, reading, writing, and exiting should be handled by this guy and nobody else. And we need a way for it to know that, and for each stream there will be a signal handler. So for each of this thing there would be a signal handler. Okay, so there's a stream, and this signal handler will only be for this particular stream. Okay, so if we go above wherever that handle command function was, so this is where we are getting the stream. And we are getting it from here. So somebody gave us good stream, and that's all we require. We go to handle connection, and this is the person who owns the stream. So this guy is responsible for replicating and everything. Okay, why do we need a sender here? Who sent us a sender, and what is the use of this? This is the sender, and they send us the sender so that they can send the stream to us. But we don't want stream, we just want data, that's all. So we need a way to, so there should be just a receiver corresponding to the sender, and that's all. So basically sending data should also be handled by this thing. Okay, there should not be a separate thread handling this whole thing. So in this handle connection, we reach here, we got the request, we process all of them normally. The only issue is like if we need a lock and everything here, but maybe lock is not a good idea here. We don't want to send stream anywhere. This is a resource, and this, ideally this should only handle this. So there is no need of this particular thing. And this will be just streams of streams. We don't need streams of streams, not required. We just require a stream and a sender. What is the sender will do? The sender will, let's actually go to the person, and who's the sender? What does the sender do? And who is the receiver for this guy? Okay, so receiver is used here for getting all the data. So this will be used for sending the data, and then we would require another sender here. How will this work? So let's see, there's another connection somewhere. There are multiple connections, right? Not multiple connections. If a replica is connected, okay, then this is, so these guys need to listen to some values. So there should be a sender where you will send the data to. So yeah, you will require sender. So let's call this data sender because it's very confusing. Request sender will be better. So this is where you push the messages. Let's call this request sender. Great. So it's a sync sender of vacuate where we'll be sending the request to. And we require a receiver, a global receiver for this particular connection, which will listen to all the data that is being sent from somewhere else. So let's call it request receiver. Sync. I think receivers are always sync. What is the type of this guy? This is MPSC. This is also MPSC. Okay. So so in a case when we have these requests and everything, we'll get all the signals. I don't need to send the stream anywhere. We don't require anything like that. So there is a handle signals. That is great. It will work like we want it to work. This is the case that we require when, so every of these will have one signal handler which will use this information to send. Okay, first we won't be handling signals now. The signal handling will only happen once we have replica. But if it is a master, okay, in case there is a connection that have been created, basically I'm trying to understand whether it will be, since redis is like single thing, like single threaded, right? So in here, will server started, it will set some command and then it will wait for some values. So once this wait starts, it needs to send to replicas. So this will start a signal. This will send a signal for, hey, count acknowledgements or something like that. So it will do that, and there would be multiple replicas connected to it. Okay, so there would be something called as handle receiver, but that will only happen once we have processed all of these connections. So one thing we know, that either we can have like a whole spawn of things only if there is a replica connected to it. Otherwise we don't need signal handler. Every time we will be just returning some values, right? So let's go to handle signals and just copy all of them again. Too much work here. This count act receiver will only happen from some other place. So particularly this guy won't be receiving this count act receiver. It will only be receiving count act receiver once it have become a replica. No, not a replica. So even if we receive it, then what will happen? This is confusing. Okay, so how will this work? So we have a stream and we have another stream, right? But this is same box. So this will maintain. So if a new node is added, so there will be a stream for each replica, right? Replica 1, replica 2. So these are connected to the master. And this will be stream 1, stream 2. So in this stream, I got some command called as wait or something, but this is not connected to any replica. This is connected to redis CLI. Right, and then it will be sending some command like set or something, which it will pass to each replica, and then it got wait command. So for wait command to work, it will just send some commands to wait to replicas. They will do something here. We'll get some response which will increment a global counter, and it will be notified here, and then it can return a response again. and then whether they want to send the response or not, it's something that it can decide. But yeah, at a particular thing, a stream can either be a replica stream or a client stream. So the redis client stream will get a wait command, right? So alright, so sorry for the interruption, and now we'll try to implement this. So this whole will be sync, but as soon as they know that okay, this is a replica, it will exit out of this particular synchronous thing and it will start a task. This is where the whole handling will be happening, right? So let's do it. I guess I'm slightly clear with the approach. So this is the loop, this is the whole synchronous thing where we have a request, and I don't want to have any kind of blocks. This will be just read, and there is no need of drop, and this will be stream. What is a stream? The stream is TCP stream. And this should be dot await. Okay, this is where it will read from the stream, and after this thing is done, it will read some bytes, it will respond with some bytes. We don't care about signal sender at the moment, nor this, but we care about sending the data. So we have request sender. We look for request. This guy will be sending the data to the, okay, let me just revert some code. I guess that's a easier way because this is becoming very hard for me to look at. So get stash, get, let's look at the tags. What did we do here? Here we added parallel clients. This is async signal handler. This we never required. What is this undo? So doing some stream dot push and then dot await dot unwrap. What is sync handlers? So I guess this is the commit that I want. I want this commit specifically because async signal handlers, we never wanted that. It just makes things so hard. So how will we do this? We'll check out some branch from that particular commit, and we'll swap the values there, and we'll make that the master branch, and rest of the commits will go to that branch. Sure. So we'll First, check out a particular commit, get and then we'll create a new branch called async signal handling branch, and we'll do get log. So this is the whole till master we want to see. So this let's just check the dig, which branch I'm in. I'm in this thing. Let's go to master, get check out master. Get status. Get status. This is still get. I think it's called main nowadays. Yeah. And I am here. Great. So I'll put everything that I have from here to some other branch. Sure, that can be done. This is the main. This is a signal. So we'll do cherry pick each one of them. I wish to get the whole command. I'll just copy all of them. Weird. Okay, I'll copy them and I'll do let's check this thing. Git log master main. Weird. Okay, we want to cherry pick each one of them. Okay, so we want cherry pick all of them. Now I want this to be at the top, this to be at the second, and I want this to be third. And now we'll just do And now I'll run this particular commands. Sadly, didn't work. Great. So that should work now. Okay, there's no diff with the main. Let's check out main, and let's do a tick here, and let's look for that branch that we were searching for. Yeah, let's get the log hyphen graph. Okay, so let me do get rebase. This whole thing will become drop. Okay, this is done. I don't want to push it, I want to forcefully push it. And now git push Codecrafter. And great, let's see how it goes. Right, I'll just take a break, just 5 minutes. So we have successfully reverted back all of the changes that I did, and we'll be starting from the start. Okay. Uh, so this is the handle connection, and the only thing that I need to change is I don't want to pass this TCP stream anywhere. I mean, there is a sender here which will be sending data back to the, so currently here there is a TCP stream, right, that we have. And okay, okay. So something that I'm thinking is that this sender just sends the data that it have received on that particular stream. This is just for the buffer, and there is this stream, and stream is passed down to the replica handler. So once this thing is done, this thing will exit out of the loop, and the stream will be handled by the this particular block at the top, and this sender will be just sending the values. So as soon as an await commands comes up, the wait command should send some data to the replica saying, hey, these are the things that, hey, are you acknowledged? I mean, are you alive, kind of thing. This is the sending data to the replica before replying to the client, and this is sending the request. So there is a particular thing, right? So if you got the await command, you want to, so let's take a particular case, right? So in this case, we have one replica here and replica 2 here, and there is the client, right? So it received wait command. So what this client needs to do is it needs to notify all these 2 replicas, and how it can do by sending some data to the sender. Sender will have a command that, okay, it's a replica something command. Then I wish to it will send some particular data to these places. So I just need to wrap this whole thing inside some kind of enum, and it should work. But how will this thing work? So in the end, we'll have some sender.send, right? But I don't think we use this sender inside this thing. So this sender.push, when do we push the request? After getting the response, right? But we have some new signal handlers here, and I wish to use these signals. So this is where it's receiving it. So this is where it will try to receive the signal, and then it will either send to replica or not send to replica. So send data to replica before replying to client. The signal handling should happen as soon as we got the input there. So this should happen in parallel. So this is the data sender where we'll be sending the data, and this is some other signals that we don't care for now. Okay. Data sender. Just a second. Okay, sorry for the interruption. Now we are back. Yeah, so the thing is, before sending the response, we need to calculate few things, and I somehow need to also send this data sender to these all values in between as well. So there is one data sender which talks to the replica, and then this txrx is just for well, actually we never required this txrx. It's just confusing. Why did I create tx and rx? Just for verifying whether it's a new node or not, but it could have been a struct as well. So let's ignore that. But we need to send this data sender as well inside the request handler. So this data sender, let's go to data sender. Whoever is who created this thing, they will be creating a sender. This is the sender, and this is where they have created new things. So it's a sync sender of vec of u8 and receiver of u8. But it won't be now anymore. It will be an enum called as some enum. Let's call it enum naming thing is very hard. Let's see. Master replica signal. No, this is just in a same command. So this will be stream message or something. Yeah, TCP stream message sounds better. TCP stream message, which will either be data, which is a vec of u8, and it could either be message called count aux vec of u8. Okay, so now this should be a TCP stream. Let's call it TCP stream message, and this should be called as TCP stream message. And wherever that receiver is being used, I'll just call it where's that enum? I hope this is public. Oh, because it's implied. Okay. If it is implied, then great. So this is the first error, since well, let's match data. This whole thing will be inside this thing. And this is the data. Okay, now what is the issue? Why is it still not formatting properly? Maybe I'll just close it, run it again, go to main.rs and format. Let's see, cargo build. Okay, so there is a error at line number 21. What did I do here? What the hell? This should be Tokyo main. Let's do cargo build again. Great. So now this should work. Yeah, it worked. It looks very ugly, but sure. Okay, now in case of count acknowledgement, it doesn't need to be evacuate. It should just be and there should be a data sender. This is replica.push, which we never require, but this can be just TCP stream message data, and that's all. And what is this thing? Sends the value to this synchronous channel, and the return type of this call is TCP message due to argument to this method are incorrect. The return type of this call is TCP stream message. And this is supposed to return option of TCP stream. Okay, what is the weird error? Cannot find it out. Okay, so okay, I think I forgot to change the argument here. And let's do cargo build again. And when we do this, we get some error saying replicas.push issue. Do I really care about replicas.push? Not really, right? But for now, I'll just comment it out and we'll mark it with to do. Okay, great. So this is building fine. And now we need to send this data to this data sender to to the. Can this be a global thing? I think it can be a global thing, right? Since, yeah, let it be a global thing. But if it is a global, then I need to take lock on it. Can the sender be a global thing? I think it can be a global. Sender can be global. And these all reply receiver can be normal thing. Okay, let's make it global since we require it to be there. So let's. I know this is all bad practice, but sure, what can be done? This is life. So I'll create an enum message here, and this should be public. And let's call it data sender. Data sender. It will be static. And let's go to main.rs and let's look at where this thing is being assigned. It's being assigned here, not here. And it's a sync sender of TCP message. Okay, what is the method for sync sender? How can this be created? It cannot be created. There is no new method here. So let's make it option of something. But then it will always be painful to create it. Okay, let's do it anyhow. Sure, it will be painful, but it needs to be done only once, since these all things can be shared. Okay, great. We have a data sender, and as soon as we create that data sender here, so as soon as this data sender is created, we will do what? We have to do something about it, but what specifically? Okay, I'll create a clone for this thing. So let's do data sender dot unwrap dot left global data sender, and this will be global data sender dot And let this be as usual rw lock. Does this send function ever, let's see, sender dot send, it doesn't require to be and let this be sum of sender dot clone. And expected you to type of this binding. What is this error? Expected struct data sender found enum option. Why do I feel like I can just put this into a particular state thing and it'll work? Maybe I should do it. Okay, let's see public. Great. Now this should work. It's just that whenever I'm creating a state, I should ensure that this thing exists. It should be easy because I can just assign it to none. Let's go to main.rs and let's fix this. Node.write. Pretty sure I'm doing somewhere node.write. Node.write. There should be somewhere where I'm doing replicas dot push something. And where did I get this replicas from is a mystery. Not a mystery actually, it's pretty easy to find out. I did it by copying this thing and I'll go to the place where we get sender and receiver and we'll paste it there. There should be no dot data sender. Sender dot clone. So now this should work. Let's see if it works or not. Let's do cargo build, and it's not working. There's some, okay. And it's not working still. And finally it's working here. And now the thing that we need to do is what? Not sure, but every stream should reply with the replica count soon enough, right? Yeah. So basically we'll get some error here, and I just need to go to lib.rs, where we are actually getting, when we are actually getting the command for wait. There should be some command for wait, and here it is. Sure. So we'll be waiting for a while, but before doing that, we'll send a message that, hey, please start a counter for me. I wish to compare the number of replicas, right? So let's do that. Let's start a counter somewhere. Now let's take the global node. I think somewhere there is a place where we have taken node as a mutable. Somewhere here. Let node is equals to node dot write dot. Oh, actually send doesn't need to be. So just let node is equals to node dot read dot unwrap dot master. And this will be node here. What is this node? Node is a read card. Sure. So back to where we were in this place. And now we will node dot data sender dot map something called as sender, which will be sender dot send some data that will be TCP stream message dot count talk. And the thing cannot move out of it, so I won't be doing that anymore. Otherwise the read will be pretty long. So let's go to that read command. Wait, and then there is this data sender. Great. Data sender dot. What is the sender? Sender is a sync sender. And what does the send command do? Send command just takes a reference of that thing and should be good. Okay, so it needs to be as ref. Consuming the self. So it should be dot read dot as ref. Why is this not working? Let's see. Cargo build. So this data center should be as a reference. And this should be cargo build. And yeah, it's working. And now I just need to send few commands to the replicas and it should work. Great. So now the streams, who owns the stream? The only person who owns the streams is that particular function in the main file. So they have the whole stream and now they can send some data there. So we'll do that only. Let's go to main.rs and I wish to check that data by, actually, let's see, async. Yeah. And now this is the whole async signal handlers. What I wanted to check specifically was there was a big message that I created. Yeah, there it is. Let's go to the main.rs. We are here. And let's go to the place where we will be listening to this particular thing. And it's here. Okay, now we have repl get and what we'll do is we'll stream through all of them and we'll write some result there. This is not just simply writing some results. This will be us writing some meaningful things. And the biggest thing is where are we using this particular data in here? I feel like I can like reuse this thing. Sure, we have this sending something to replica, and this is where they are sending the data. If it is some weird value like that. But if it is not like that, then what can I do is I can stream through all the streams. That's all I require. And we'll be sending something of my own. And what will that be? What will that be? Obviously, it will be some magical thing. And what is a stream? Sure. We need to copy this as well. And for each one of them, we'll be sending this particular message called replication. Let's do stream dot write. And as soon as we receive this, there are two things that we need to do. First, we need to set the replica count to 0, and then we'll send these commands to each of the replicas. And whoever replies to it will be good person or something. Okay, stream dot write. What was that function? Stream dot write all. And this will be stream replication attack. Okay, and then these things will be they won't be replying now, and but we'll be reading after this. And this will return how much have been written to, I guess. Okay, and I think I can just move this outside. I can just reduce the number of indentation calls that we have. And once this is done, we'll read from it, stream.read, and there's some buffer, something we require here. Let's create a random buffer. Let's see, where is the request buffer? Sure. And now this request buffer will be used here. And whatever that value is, let n, this should be dot await as well, and this should be let request, let response equals to request buffer of n. Request buffer dot slice why is this n view size? Okay, so let request equals to request buffer responsive, and this will be somewhere of n. But if I write n here, it never works. But that's okay. Let response be equals to response of n. So who will unwrap it? And we should do println replica. I replied with something. This will be I guess. And some response. And this will be I. Okay, so this is a big debug statement. Maybe I'll just convert it to a string. String lossy string from UTF-8 lossy, and this will be your response. And let's cargo build again. And yeah, let's get that -p everything. I'm feeling very optimistic now. Let's see, get push Codecrafter and get status. Okay, get commit -m, adding global data sender, get push Codecrafter, and now it should work. Okay, this is very weird. What happened now? Let's run the Redis spawn server. Like usually I should be writing some test cases so that if this thing ever happens again, oh, this is spawn Redis server.sh. Okay, logs from my program will appear there, but nothing have occurred yet. So I'll just start a Redis fly, and that is also not working. Okay, this is very weird. I feel like this is something taking a lock and not releasing it. But who would that be? I think that's probably me. But why is it so? Let's check out. Let's go to main function. This is the main function, and what we see, we listen to this, we handle the replication, we create the stream, we read the node, and we do node dot data center something, and I am supposed to drop the node as well here. Once this is done, I guess the program should work. Let's see if we get rest of the logs, and yeah, we did get rest of the logs. And just to verify, do I get response of ping? Yeah, we do. Okay, let's exit it. And weird thing that this is happening. Releasing the right lock. Get push Codecrafter. Right, so yeah, I know what's happened. We added a to do for this specifically somewhere here, so I'll just remove it and we'll uncomment it, and I'll just go to the place where this replica is created. Dot replica, and this is the one. And instead of having it as a this thing, let's have it as a atomic U size. Atomic U size. Great. Why do we need clone? If we don't have clone, then what will happen? Will it build? Let's see if it will build or not. Great. So wherever this thing is being used, let's go there. It's being used here, and just we can do atomic U size new of 0. And where else this thing is being used? Here it's being used, and we can make it to be replicas. It can be simple read, right? And what is the issue now? Some weird issue. Oh, so this should be a whole U size, and this is an atomic U size. Sure, replicas dot. Okay. I think I know what is this. Replicas dot load, and this should be some ordering. This should be relaxed. Great. And this should work now. Okay, we'll do the load here as well. Great, and now we'll go to the next part, which is here. This will be an atomic U size. So let's call this node.replicas dot replicas dot increment fetch add 1 comma ordering comma relaxed, and this will be something like this. What is this thing? This is a U size. Okay, so I guess we are done. Just a cargo build again, and it worked. Now I hope the test cases passes. Let me just add something. Just to get what happened. Replaced replica with atomic size. Let's do git push code crafter. Okay, great. So we got to the point where Yeah, we got to the point where there were some test cases where they are testing this thing. And after this is done, we need to check how things are going on. But something stopped here. Yeah, but the replication 18 is still failing. It expects something to be sent after every set command. But why though? Yeah. Error reading from TCP stream, program returned successfully and whatnot. But there could be some error as well, right? Like if, yeah, there can be. Okay, so replica 3, somehow it's not sending this response because error reading from TCP stream. And error at some error, no errors is being given here. Error reading from TCP stream. This is the only place where it's being done. So somewhere here, because they close the stream. Okay, so we are back. Let's get started. Okay, so program is still failing, but what I want to check now is why it's failing. Why is it not available? This is replication 18 and there should be some logs. So this says so it got the wait command and it returned the output of this, and there was a set foo, and then it received repl-conf get-ack, and then it received 31 something. Okay, before doing this, I see like there's a comment mentioned on the exercise saying that this thing, I'm not supposed to send a get-ack to the replica if there was no previous write operation pending. What does this mean? So you cannot send get-ack to the replica if there was no previous write operation pending. If any of the write commands started before, if not, return the number of connected replicas. If any of the write commands started before. What do you mean by this? So it will then start multiple replicas that connect to your server, each complete handshake. The tester will then connect to your master's redis client, not one of the replica, and send multiple write commands interleaved with wait commands. Must wait until either one replica has processed previous command or 500 ms have passed. Must wait until either two replicas have processed a command. Okay. The wait command should return when either A, the specified number of replicas have acknowledged the command, or the timeout expires. The wait command should always return the number of replicas that have acknowledged the command even if the timeout expires. The return number of replicas might be lesser or greater than the expected number of replicas. Okay. Let's see, view instruction. So this is the way we can check. I wish to see where is the what concepts. What is this concept? Okay, what is this forum? Let's check the forum. So replication 18, we have issues with replication 18, and what is the issue specifically? The issue is error reading from TCP stream, but there is nothing given after this point. And what might it be? Error reading from TCP stream. Sorry, yeah. Error reading from TCP stream. Then this is the error that we wish to send, and this can be something weird like this. Let's also ensure that we are increasing the count as well. So how do we do that? We'll do that by checking which commands. First we'll reset the count. Every time we get the wait command, we'll reset the count. So where is that wait command? It's in the lib.rs. Wait. Yeah, this is the wait command, and before actually starting with this thing, we'll make sure that we here we'll reset the number of this thing, no dot write dot unwrap dot replicas dot store dot 0, and there should be ordering of relaxed. So once this is done, we have now written 0 to that particular location, and now we'll start listening for count acknowledgements, which is here, and every time we receive a response that is not an error, so this will say either we got the response or we didn't get the response. So let's match over this. And let's fill up the arms. Somehow filling up the arms and go to the main function. Something really weird is happening here. Okay. And this is done, and now we will look at the error case. Great, so now we have everything that we require, other than we need to fix the output here. So let's fix the output by there should be something in the main.rs when our replica is connected. Hmm. And we'll say replica replied with this. Okay, now we are incrementing the results every time. Increment replica count every count replica on each wait. Let's see how it goes. Right. So now, if we look at the command number 16, we see that there is a error saying something like what is it saying? It is saying, well, this is replication 16. So let's go to replication 16th program. I feel later stages exercise, they are not well documented, but this is the 16th one. So wait with no replicas. A Redis client will then connect to your master and send wait 0 6000. It will expect to receive 0 back immediately since no replicas are connected. You can hardcode 0 as a response for the wait command in this stage. We'll get tracking the number of replicas and responding accordingly in the next stages. So if it is 0, then I should reply with 0 only. Okay, where is that particular let's search for wait 2, and this is here, and it says that if the replica count is less than or equals to n, then I should just return immediately. So get commit -m, return immediately if 0 replicas. Get push Codecrafter. Okay, this program is failing in a very weird way. So only one way to check, that is check it manually. This guy wait 0 60,000, and this is taking too long. Okay. So nobody is signifying this conditional variable that it should not wait for particular output. So what can we do here? We can, for now, who is calling the cvar? Basically, we need to wait for particular amount of time, and yeah. So a particular atomic use size, there should be a conditional variable associated with that replica count, and whenever that replica count is updated, this thing should be notified of that. So this is stored, so 0 is done. Let's see atomic use size conditional variable. And converts, okay. Okay, this method in terms of compare exchange tree can suppose from the same drawback. In particular methods will not What is this? Compare exchange. So compare and exchange we can be used for this, but I don't want to really use it. Is there any way to know if this has been modified or not? What is this fetch update? Okay, so there's a spin loop hint. Okay, so this is used okay, while back on our current thread we wait for the value to be set. The spin loop is a hint to the CPU that we are waiting, but probably not for very long. And this will now so there should be two loops, right? So this should be inside a select statement. Okay, Tokyo or on the same thread, I guess. I don't want to use conditional variable here. This is so much like magic. I really don't know how to use this. So let's remove conditional variables and the mutex thing. Okay, so this is magic. So yeah, in the end we'll just wait for particular duration and we'll return the result. And let's go to main.rs, and wherever that replica count we are increasing, right? Let's remove that from there. I feel we don't need to do this here, like at all. No, this is good. At the main here. Sure, this is great since we have the result and everything. And we are just increasing the replica count. But do I need this particular thing? Not really, right? So this will add values to the replica thing. So busy wait spin log. Upon receiving the spin loop signal, the processor can optimize behavior, for example, saving power or switching hyper threads. This function is different from threaded yield now, which directly yields to the system scheduler, where spin loop does not interact with the operating system. A common use case for spin loop is implementing bounded optimistic spinning in a CS loop in synchronization primitive. To avoid problems like priority inversion, it is strongly recommended that the spin loop is terminated after a finite amount of iteration and an appropriate blocking syscall is made. Note: on platforms that do not support receiving spin loop hint, this function does not do anything at all. What is this join? Oh, this is for thread to be completed. Okay, that join. So there is a conditional variables. Okay, I guess I can let it be here, even though I'm not really comfortable using conditional variables. In the lib.rs, we'll do undo again and again until we reach a point where it was correct. This is the place where it's correct, and now I'll be just going to the main.rs, and whenever we are incrementing the replicas, will also ensure that a particular this mutex is used to notify the thread that this is done, and where it will be done, this will be done at this point. And let's see if it works. Spawn redis server.sh, and this will keep waiting because it's 0. If it is 0, then it will never work. Let's actually hard code 0, that if it is 0, then just return the output. What does this return? Store the value in the atomic integer, returning the previous value. Let result equals to this. If result is equals to 0, Okay, let's run the program again. So in the end it was 0, but still not working, I guess. And this is equals to what here? This is n. It will compare with n, and if result is equals to 0, which it is, right? In the starting, the result will be equals to 0. But if it is not equals to 0, then we'll do something here. Great. So nothing will be done, and this will exit early. And even this won't be done. So this whole thing will come out of here. And then it will just serialize the ordering as relaxed. Okay. But then why is it not working here? So it got the wait command and result is not equals to 0. So we don't need to wait if n is equals to 0, right? Why am I doing this whole thing? Some milliseconds, and some millisecond values would be given here, and once we have some milliseconds, we'll use them for something. But we don't need to wait for these things, since if n is equals to 0, then I'll break out of this. Let's do cargo build and let's release it again. Great, so this is working. If I just have one, we'll wait for some time and then it should return. What time exactly? This is 60,000, which is a lot. Just wait for 600 milliseconds and yeah, we returned. So let's do get status. Get that -p. Sure. Don't wait if 0 is given. Let's see how it goes. Okay, so we got our error reading from TCP stream, and then we will be reading, what is this, 4 and 5, what does this mean? Error reading from TCP stream, and now we'll go to the what is this error saying? Some new resp value error. Okay, where is that place? Here, this is result, that is the previous value it had, and how many replicas replied with some answer 0 1, some replica value here, and then we'll return the answer. The biggest issue is why is it failing? It's failing because of connection reset by peer. And then there's a replica 3 which says received set foo123 and received replicon get awk, and then there should be like replica 1 returned with 03 replied with this thing, 14 replied with nothing, and 25 replied with nothing. Maybe they replied with something but we didn't really read it. But it can never be that. If there is no response, then how can it be? Basically, if n is equals to 0, then I should never increment this thing. I should consider it to be error only. Let's do result. This should be dt and this will be match res. It should be if res start is okay, else is okay, and res dot unwrap dot equals to 0, not equals to 0, and let n equals to res dot unwrap. Res dot result dot unwrap error. Then the contained OK value. What is this thing? Returns the contained OK value or compute it from a closure. Okay, so it will either return the 0 unwrap or else. So some error is there, and then there is a result dot unwrap. Result dot is okay, and I guess we should match only, but it's just there is a special condition for this thing. What the hell? So we have n and error, and if n is equal to 0, I should just continue with the loop, because it doesn't matter. Should we consider this to be an error case? So what is happening is there is a certain issue where this thing is 0. The request buffer came to be 0. Replied with what? Replied with something. Let's call it, I'll call it n comma. Okay, get status, get add hyphen p, get commit hyphen m, printing stream bytes, get push and get push Codecrafter. Okay, so we are back, and I see that there were some streams which returned 0, which is okay. Well, not okay, but still, this should have been removed from there because it's failing here, not there. So if replica 13 received set foo, so after every set, it should return one wait acknowledgement automatically. I don't think that's how it should be, but let's actually read the logs now. Sending star 2 to replica 0 to replica 1 to replica 3. Okay, this is great. This is all replica 18 received pong. Let's actually see the output here. So what do you mean by acknowledgement with commands? Let's Google this, like on the Redis documentation. RepelConf, and this should be how do I get the we were incorrectly including the handshake byte in the count. We have to fix this here and should be deployed shortly. Okay, so replication 18 have some bugs. Can I read the test cases somehow, somewhere? I guess I can. this is also internal command. Just a second. Okay, so this is offset tracking, and in here we need to check what do we need to check? Number of bytes of command is processed. The count is called offset. When a master sends get a command to replica, the replica is expected to respond with some offset. The returned offset should only include the number of bytes command processed before receiving the. As an example, let's say this is the one, the master send get a star again, and then we get the full response. Okay, the master then sends a ping command to the replica. Master do this periodically notify that this. Okay, but it never said anything about like this is something necessary. What do you mean by no command? Will then connect with this thing. The integer even if weight is number. Okay. Okay, so it doesn't matter how big the number came as an input. It should respond answer with the amount of replicas. Right, so in this thing now, and then we'll run a wait command. And what does redis wait command means? It means a few remarks. When wait returns, all the previous write commands sent in the context of the current connection are guaranteed to be received by the number of replicas returned by wait. Okay, when wait returns, all the previous write commands sent in the context of the current connection are guaranteed to be received by the number of replicas returned by wait. If the command is sent as part of multi-transaction, a timeout of 0 means to block forever. Since wait returns the number of replicas reached both in case of failure and success, the client should check that the return value is equals to or greater to the replication level demanded. This command blocks the current client until all the previous write commands are successfully transferred and acknowledged by at least the specified number of replicas. If the timeout specified in millisecond is reached, the command returns even if the specified number of replicas were not yet reached. The command will always return the number of replicas that acknowledge the write command sent by the current client before the wait command, both the case where the specified number of replicas are reached or when the timeout is reached. So basically I should just flush that whole stream and write everything that I have to, if this is the case. So considering this, if I ever receive count acknowledgement, I should go ahead and write everything I have in my command buffer, and then I should continue. So I think this should be called as something like send data. But what is that data? So this will be pushing to command buffer, And once it's pushed to the command buffer, there should be this whole thing. This thing doesn't require command buffer, just this thing just requires stream, and that's all. So what do we call this? This is called as, so I should do this every time this thing is done. There should be a new function somewhere here. Can I make an internal function in this? I think I can, right? Fn send all data. And this will be a sync function. What does it require? It requires user streams. Sure, so user stream can be a top level something. Okay, so this is supposed to be here, and this is a command buffer. So let fn is equals to something like this. This is a sync function which takes values here, and I won't be naming it here. Async closes are unstable. Okay, so weird. So then I have to copy the commands. I guess that's the only way to go. So this is great, and this is pushing the values of user stream in here. So this whole function of user stream and everything, this needs to be copied from here. That is from here to here. So as soon as I receive this thing, I'll be first of all writing whatever I have for that particular stream offset. So I'll be cleaning this whole thing up. So if it is an acknowledgement, I'll do this first, and if it is data, then we'll be pushing it. So yeah, just a second. Yeah, just a second. I'll be taking a small break. Have something to attend. Okay, back. So yeah, the main issue is there is a lot of duplicates here now, and I don't wish to do that. What I'll do is I'll just copy this particular message and put it here. So basically, this is all the data that we need to send, and in this command buffer dot push of data, basically, if let what was that particular stream, TCP stream message of data, then we'll do this thing. So I'm just thinking, what is the issue here? Like, oh, this is the issue. So I'll remove this thing here, and so we'll be receiving some data in receiver, and the thing that we need to check is if let's say if let TCP stream of message of of data of data, and if data.len is equal to 0, then we'll continue the loop. Great, and if it is stream, then we'll get the streams. If it is data, we'll push it to command buffer, and if it is user stream, then we'll ignore it. And after that, once we have everything inside our command buffer, we'll iterate through all the streams. We'll push everything that we have here. So, and if there's some error, then we'll break, otherwise we'll send data to the replica. Once all of this thing is done, we'll remove the data from the useless streams. And after useless streams, if we come to know that there is something else needs to be written, like if it is a get tag or something, then we'll do that here. Basically this whole thing will be doing now at this place. Yeah, so if this will also be inside a bracket, if let TCP stream at the rate count tag is equals to data, and where is this data defined? This data defined is here. Great. And now we'll be having user streams and normal streams. So we have something called as user stream. Let's do this in the end. And this should be happening after that whole data is buffered, and this is inside the stream. So somewhere here it should be happening. And there is a lot of brackets that needs to be closed in the end. Partially moved data. Okay. So this is new data that we'll get, and this should be inside the stream. Correct? Value partially moved here. Okay, it's not a big thing. Basically, there should be a place where somebody should have decided that, okay, this is the data that needs to be sent. Okay, so now the data is partially moved there, but we don't really care much about that piece, since the last amount of data will be here if it is a kind of a data. If it is not, then we just want to mark if it is data or not, right? So a simple thing that we can do is let is awk is equals to false, and will do else is awk equals to true. and this should be mutable. And I don't need to worry about data being written here. Where? Here. Basically I can just do is awk. Let's do cargo build. Okay, so this is the place where the whole stream gets enumerated, and then user streams are removed after that point. If one of those streams are useless, we'll break and then we'll go ahead, and we'll keep doing this until we, the user stream should be a set instead of a vector. So let's handle that. Set well, let's not do it here, let's do it at the bottom when we have list of all the useless streams. So we broke out of this thing, and then inside the acknowledgement also, if there is a stream which is useless, we'll also write them down. Okay. Okay, we'll do this thing. Okay. And now we will put this into user streams, and this should be now set hash set from what is the user stream? It's a vec of new size. From takes an iterator. From user stream dot into iter. What is this? Cargo build. So use size is not implemented for this guy. So useless streams dot push won't work here because those indexes might change. Okay, so we'll do what? Into iter. What does it say? The trait hash rate from is not defined. So hash rate from iter. It's a value from an iterator. Hash rate new from iter. Hash rate new okay let hash equals to hash set dot new, and for I in useless streams, and this should be hash dot insert. Right. Okay, so mismatched delimiters can be solved here. Okay, so I guess this should work better now. Let's see if it helps. I don't think it will help, but let's still see. Adding flushing data before sending get awk. Okay, so now we are, I think, emptying that whole stream, and then we also got some error saying replied with 0, replied with 0. We'll also remove it from the streams. Where is that replied with 0? Yeah, so if ever in a condition, if we ever receive n equals to 0, we'll push into the useless streams, right? And I guess we don't need to, if len of if n is equals to 0, we'll continue. Can we break? We'll push it to useless streams, and then we'll break. And if there is some error again, we'll remove it from the stream, and then if is acknowledgement, we'll try to write it. And if we ever, while reading that, if we ever get 0 response, then we'll also write it to useless stream start push of I. And we should now I guess continue back, since this is not required, but AJAC is something that will be done for each data, I guess. And then we'll close it. But once I found out that this stream is useless, I'll continue the loop. Whatever loop this is, I'll continue with it. Continue with this. And how is this? Which loop is this? This is this loop for data in command buffer. Not this loop. This is stream loop. So we'll go to the next stream and we'll try to create that stream. And what about this guy? So yeah, this loop should be the biggest one of all of them, and it is. Push into useless streams if the response size is 0. Okay, so we are now getting some error saying error reading from TCP stream, and then we got a panic because index 3 is not there at all. So how do we ensure that new streams are pushed to the places where it should be, I guess, a hash map of whatever stream count it is. Let's give them a unique name, and while iterating over it, just get the number and then remove it from the hash set so that they don't collide with each other. So it should be a parallel hash map or something, and they should all be given a unique number. Yeah, that's so. Just get the latest number and then insert it. But that's not the solution for whatever issue we are facing. But I'm hoping once we do that, at least we need to do it, and I'm just delaying the inevitable. That is very true. So wherever I'm pushing it inside this master block, and then we have streams.push, and this is the offset, and this is streams.write, this is streams.clone. It's something here. Let's call it hash map, not hash map, b3 map of use size comma TCP stream. and this should be now hash, sorry, b-tree map dot new. Okay, so there is a b-tree map now, and whoever is using streams, please come forward. I wish to make things difficult for you now. Yeah, there it is. Not really. Not this difficult. So there should be some offset. And this should always be inserting into this place. First, get the let max I is equals to streams dot get key keys into dot max keys dot iter dot max, and that's it. And max will return optional, and this will be max dot or return the option if it contains a value, otherwise return opt b or 0. This should be maximum value that it contains. Stream start insert, so it will take key, that is for sure max plus 1, and what do you mean by that? The argument of these functions are incorrect. How can you say that? Max dot or else unwrap or else 0. Now what is the issue, sir? Max, this will return all the keys reference, and max dot map k. What is k? K is a u size, so it should be star k or unwrap or else 0. Great, and now will be stream start delete dot remove a particular I. And now will be done, almost done, once we have all the access to the I and offset. So it should be key value pair. Okay, so this is weird. It should already have given key value maps. So and now this is borrowed as mutable. More than once at a time. I'm pretty sure that this thing is closing here. Okay, let's run the cargo build and check the error. So I'm using it in this for loop. Here I'm using it. So this is where it's borrowed mutably, but pretty sure this is, oh, this is the loop for the data and receiver, which will never end. Okay, okay. Which is okay, I think, since this is the only place where this will be used. I am not copying it, am I? Not really. Just a second. I have to take a break. Okay, so this is awesomely great. Am I audible now? Okay, great. So where were we? We were here trying to. Okay, so right, where were we? Okay. Right. So now the things that we will do is something that I cannot tell anyone. That is how to kill the dragons and the monsters around us. Okay, great. So now we are back into the stream, and now we'll be looking at what were we trying to do. Yeah, so now most probably this still won't work because somehow hashtag is mutably borrowed, but the borrow ends here. So weird thing. What is the stream? The stream is a card. What is the stream? This is a right card of B tree map. So what will we do is until this particular stream is processed, how will we process this? We'll do let mute kvator into it. And now we will, it's a usize of TCP stream of usize, and okay, great. So this intuiter will move the value. What is kvator? Kvator is vita mutable, and then the issue is cannot borrow streams as mutable more than once at a time. But I have not done that yet. Okay, let's streams dot mutable iter mute. So first mutable borrow occurs here and then second mutable borrow occurs there. Where is this thing? All of them are in a same block. But the issue is mainly that it's behind an await block. So first mutable borrow occurs here. And cannot I just remove these values? Okay, how about we remove things from here directly? Let's do instead of iter mute, let's do streams dot iter mute. What do you call that? Entries? Yes, it's the entries API. Let's just do iter. This should be just keys. Let mutable stream comma mute offset is equals to streams dot get to mutable value called I. This should be unwrap. Okay, so this we have here, this is offset. Most probably it's a mutable something. Okay, so I'll just let keys equals to stream dot keys dot this should be from vec. Vec dot from or new, and this is from extend Okay, now this is a big issue since this is a big hash map and people can insert into hash map willy-nilly. Okay, the issue is cannot borrow streams later. Weird. I'm not sure how this will work, but we require something more here. Cannot borrow stream as mutable more than once as a second mutable borrow occurs here at a time. Since this is inside an await point, so there should not be any await after this thing, but this whole thing is inside a loop. So in this Tokyo spawn, as soon as we find something that we don't require, I should be able to remove from there. Like I should be able to delete stream and everything. Stream dot entries. So this should be called as entry. Into keys, into values, and this should be iter. Entries, last entry, first entry. Remove entry. This will return some entry, but it needs a key, some query. First entry, last entry. So I'll keep removing it. And we'll keep pushing to it. But how can we ensure that okay, let's see. While let sum of entry is equals to streams dot first entry. Let entries equals to vec of something. What is this? Now this is an occupied entry, so entry dot delete, entry dot remove entry. Remove takes the value of the entry out of the map and returns it, and this will return the entry itself, but it won't push it back. Okay, so let this be, let something be equals to, what do you call this thing? This should be called as I comma stream comma offset to. This should be mute. And what is this? Stream dot write all. This should also be a mutable value. And now we'll be using this in the end. And basically, if ever we don't like, if it is a user string, yeah, I should just call it here. Let is useless equals to false. So we remove the entries and we just process them, and if it is useless, we'll remove it forever. And we'll call it a new hash map. Let new hash map equals to new map equals to b-tree map colon new. Sure, we'll do that later. We'll just break it and we'll call it is useless, and this should be true. This is command buffer and this is acknowledgement. Once everything is done here, what is this command? This is some entry, so we'll call this new hash map, new map dot push dot insert I comma, what is this, stream comma offset. If I borrow it as mutable, then it should work. Okay. Never used is useless equals to true, and then we'll continue the loop. Cannot continue the loop here. So this acknowledgement will break somewhere here. Where is this loop? Where are we breaking out of? Why are we breaking out of this loop? It should be called is useless. So is useless equals to true, and then we will not write basically anything. And we will write and we'll read from here. And if we ever find out that this thing is useless, whatever this is, we need to continue things here. So let's call this and then continue. Right, so now this is greatly done. This is, will come out of the loop here. This is the loop. This is the whole is act command, and then this is the whole while let command. And here is the string, and we'll break. We'll set as users to be true, and then we'll use that thing to our benefit. Since now we won't be sending any data to the rest of the stream, we'll break it out, and then we'll, so in the end, new map have everything that we require. We don't require this whole thing. New map, and now we'll just replace that map with something. Stream start swap. What is split off? So for I in new map, streams dot insert to I comma something. The return type of this call is this due to type of arguments passed. New map dot entries. Sum of entry, and this will be insert let k comma v be equals to entry dot remove entry, and with this should be k comma v. And this thing is not required anymore. Basically, if not is useless, okay. Is useless equals to true, and where else is this thing is? Okay, so now there is one more place where we are doing this, and that is here. Okay, let's see, get add -p, get commit -m, using b-tree map to keep streams. And voila, we still have the same error, but this time I don't think we'll see that weird thing previously that we used to see. So it's saying replica 1 column 4 replied with 35 into 3, so not 35 is the size, *3 star repl act. This is value 31. 31 is the answer here, and then it is supposed to connection reset by peer. So this is saying received set, but afterward it didn't receive anything. So is it supposed to send way repl again or not? Is something that I'm not sure of. So replica 1 returned redis cli repl act 31, great, and then it also received get awk, and replica 3 received some set value, but it didn't receive the get awk value. I somehow feel that this replica was removed from the cluster. Sending commands to replica, new replica being removed. Let's see if such things are there or not. So replica is errored with else E println removing replica I comma stream. So Tokyo TCP stream doesn't implement the trait display. I'm sure this does. Replica. Replica. Removing replica. Removing replica. And these are the only two places where we've done. Get commit -m, adding logs and get push Codecrafter. Okay, so now we'll be removing replica. Like let's searching for the log here. So we never got that log. Okay, so one thing is maybe the replica was never meant, is not being removed at all. First thing might be that it's not printing this thing. Other thing is the is useless parameter. Is it being set to false every time? Yeah, don't think so. Okay. Okay, I somehow feel that this will still fail. And I'm right. ये चांद के पहाड़ में So I guess this happened not that far. Okay, so poll event D, file descriptor 10. Okay, so this removed the thing from there. Okay. Because of broken pipe. Okay, so no content received. It received set, but it never received the other command. Why did it not receive the other command? Maybe because it was removed from the set. But if I don't ever remove it from the set, then how will it work? Maybe I just send it to all the sets, then it should work. Just a second, I'll be back. Okay, so we're back. Let's see. So it's still failing like very weirdly. No content received, so it should be getting it. So what I'll do for now is I'll remove this code for removing things. So even if it is this thing, I'll let it be happen. To do remove it here. Okay, so now we'll never be removing those streams, and let's see how it looks like. Not removing streams. Okay, so if I decide not to remove stream, then I'll get this error reading from TCP stream. I somehow feel this is the same thing as before. Yeah. Let's search for all the to-dos. There are 3 to-dos. One is for sure. Hmm. Okay, get status. Removing streams. Get push. Get push Codecrafter. So let's look into why this particular thing is failing. Because if we look at the Let's see forum. Where is this challenge 6? Okay. Okay, so this is just a bug. Let's search for replication 18. What was the actual error message? Connection reset by peer. Okay, my chain is almost entirely in perform await, which sends a replicon get a command to all replicas when reads the response. I have noticed that I do not get error about resetting the connection if I don't read the response from the replicas. That leads me to think that the error must be coming from how the test runner handles the stream. I have tested this locally. Okay, so nothing useful in here. There are few topics that are not getting response when replica is sent to the replica. Any help regarding this will be appreciated. We are going to put an instruction in this stage. It's expected that some replicas will not send acknowledgement back. Whether your program can accurately identify replicas which did not send ARC versus that didn't. Replica doesn't respond in time. It's busy processing the replication stream and hasn't hit the getAC command yet. Okay, so I'm getting both of them. No response was received. If you could send an email code snippet, that would be useful for us to look through. Seems as though code execution is terminated and then nothing is returned to the client from a Redis server. Okay, so I guess one thing we can do is there's this error reading from TCP stream, right? And when we'll be getting this particular error, we'll be getting this in this case when we have some request buffer. So it did read some request buffer and then it failed. Can I print the request buffer? I guess I can. Let's see why it's failing. And the other thing was error expected start of new resp values, no content received. So in the end the program ended great, but let's see. painting the request. Okay, so I'm getting a weird error. Maybe I should try to convert it to some kind of string. Okay, so no content received, expected start for a new resp values. Why do I feel like should I send it after every set commands then? So not sure if this will be completed ever or not, but we let's see. Okay. Okay, weird. I don't think a lot of people have reached 18th stage. Okay, so received something. Okay. Um, so some commands won't respond back to this thing. It will to find out that I'm not supposed to send getAct to the replicas if there was no previous write operations pending. When I was implementing this as a test to the previous stage, wait with no commands kept failing. I'm not supposed to send getAct to the replicas if there was no previous write operation pending. Not send getAct to the replicas if there was no previous write operations pending. So if there is no pending, then I don't need to send getAct. If there is no previous write operations pending. If there are no previous write operations, then I don't need to send getAuth. But if there are some write operations pending, then I need to send getAuth to them. Weird. 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 So this who received this thing? Was it some replica? I want to see the test cases of Codecrafters. Codecrafter test GitHub. Redis. Okay, somebody's done here. Okay, this is the Redis tester. And now I'll be looking at the code for this. Where is the 18th file? Why is there xrange, xadd, xread? What is this thing? Do we even have this whole thing? I don't think we require all of this thing, but let's see. This is for the response, and these are the test cases. These are all these scenarios. Test echo, test replica. Oh, there it is. Wait command. Remember zero offset. Let's see. Wait.go. Write command is a command will issue the master. Wait replica count is the number of replicas will specify in the wait command. And wait timeout. Actual number of awks. Boot the user's code as a Redis master. Spawn multiple replicas and have each perform a handshake with the master. Connect to master and execute run wait test. Issue a write command to the master. Issue a wait command with wait replica count as the expected number of replicas. Read propagated command on replicas plus respond to subset of get awks. Assert that response of wait command is actual number of acknowledgement. Assert The response of wait command is actual number of ACK. Assert that wait command returned after the timeout. Read propagated commands on replicas plus respond to the subset of get aux. So why is this failing? Issue wait command with a subset of the expected number of replicas. The subset as the expected number of replicas. Read propagated command on replicas plus we received so according to test cases, we are not doing anything wrong per se, but it seems like there is okay, what will happen of the set command? Write command to master. Issue wait command with wait replica count as expected number of replicas. Read propagated command of replicas plus respond to subset of get awk. Assert response of wait command is actual number of ACK. Where can we read the propagated test? Propagated command. Read propagated command to replicas plus respond to subset of get aux. Okay. And this is where we will be reading if it is a select command, then do this. Otherwise, receive get a command test case. Receive value test case and receive get a command test case. Okay, and where is this test cases coming from? Okay, there is a test case folder. Inside internal, there it is, and this is saying receive value test case. Okay, so there is a found data, otherwise there is this weird error called, what is it called? It's called expected something and got something. So received empty, no content received error. t.assertion dot run of value. So this is should skip unread data check, and assertion says new command assertion, where there is a command given, and where is this command coming from? This is coming from whoever is calling this. So this is wait test write command and actual number of awks. What is this write command? So write command is set foo123, and in other case is set bars. So this is run wait test with set foo123 command. So we have received set 123. That is perfectly okay. Okay, there is some arguments. Read the propagate command on replicas plus respond to subset of acknowledgements. Assert response of wait command is replica count. It was all the replicas we received. Set command in order. We then assert that across all the replicas we received set commands in order. Read propagated commands on replicas plus respond to subset of getAux. So what I understand is I should never remove values from the replica. Okay, so we have never received the command that we wanted here. So the replicas being added, but it doesn't make sense. So one thing what I understand is that this remove entry thing, if I don't do this and I do entry dot get entry dot key should give us the key, and entry dot get. So what this will do, this will gets a reference to the key and gets a reference to this thing. And let's do cargo build. Okay, so now the weird part that I am somehow missing removing values from there. So it's quite possible that I might not do it, but which case I won't be doing it? When there is no data in command buffer. Yeah, that is quite possible, right? But then is useless will be false. I'll be keeping this. Maybe what I should do is maybe check the size of the older value and then compare with the whatever I have. That's the best way, I guess. Let's see the old size and the new size. That's what we want. So let old size equals to streams dot size dot len, and we want new size, that is here we want new size. Let new size equals to new map dot len, and this will give us something good. And now let's see print ln have removed if new size is not equals to the old size, Adding logs for removing the streams. Okay, let's see how many have removed we have added. Okay, let's see how many removed we have. No, have removed. What the hell is this thing happening? Something very weird is happening. I'm never getting this particular thing. So what might be happening is we are breaking in the middle somewhere. For example, here. Quite possible that we are doing that. But this loop is for the entry, right? So even if we break out of this loop, we should reach this place soon. But if we're not reaching it, then what is happening? No new data is being sent. But should it depend on new data being sent? Well, yes, obviously. Of course, the data can be acknowledgement or whatnot. Okay, let's okay, Codecrafter already have that latest one. So now I'm quite frustrated, I guess. Let's stop the stream, I guess. It's too much for one day.